Hello guys, welcome back. In our last video, we discussed how data organization could go wrong with a regular data table and highlighted the importance of matching the physical layout of data with its semantics, or in short, getting data into the tidy data format. Then we introduced the tidyverse collection, which is basically an ecosystem of packages designed to work naturally with tidy data over the entire data science workflow. In this video, we are going to introduce the first package in the tidyverse, the tidyr package for tidying messy data. To tidy messy data, we need to first decide what are the variables and observations for a data analysis problem. Let's revisit our Billboard Top 100 data. Suppose we want to investigate the variation pattern in music ranks. Then the observation should be weekly ranks of individual songs. So the data in this table isn't in a great shape for analysis. The weekly ranks are spread across columns, which is fine for side-by-side eyeballing, but terrible for charting, plotting, or other analysis. So we need to tidy the data. Specifically, we need to add a colon for week and put all week values that are currently stored in column headers in this new column. And in the new representation, we will have individual rows referring to individual positions or ranks. The tidy tools for tidying messy data are provided by the tidyr package. This package was first introduced in 2015 and is still under active development. The tidyr package currently provides 5 categories of functions to get data into the tidy data format, and its toolset is continuing growing. Here, I would like to introduce the 2 most useful sets of functions, which allow us to address a majority of messy data problems. The first category contains 2 fundamental operations for data tidying, that is, converting data between long and wide forms. Between them, pivot longer makes wide data longer, while pivot wider makes long data wider. These 2 functions are part of the very recent developments of the tidyr package and are intended to supersede their already very successful counterparts, gather and spread. And we will see their examples shortly. The second category of functions are used for splitting and combining columns. Among them, separate and extract split a single column into multiple columns, while unite does the opposite, combining multiple columns into a single column. Because the application of the extract function requires the knowledge on regular expressions for string matching, we'll defer the discussion on it until we learn about text analytics. Let's consider an example that illustrates the use of the pivot longer function. As suggested by its name, pivot longer makes data sets longer. It does so by pulling data that is currently in columns into rows. To let you see the effect clearly, I only show its effect on a subset of 5 songs and their first 3 weekly ranks. As you can see, weekly ranks that were previously spread across these 3 columns are gathered into one column named position. And a new column named week is created to populate the names of the 3 original columns. And week number is now correctly stored as a variable that describes these ranks. and values in the remaining 2 columns are simply repeated as needed to match the number of observations in this new format. Now, let's inspect the function's parameters to delve into a bit more detail about its functionality. The first parameter expects a table or data frame to pivot. The second keyword describes which columns contain values that need to be spread across rows. In this case, they are columns week 1 through week 3. The syntax for specifying these columns is flexible. For example, we can select all columns between a start colon and an end colon with this sequence notation, or exclude a colon or multiple colons using this minus sign notation. And the names2 keyword gives the name of the variable that will be created from the data stored in the column headers. That is week in this example. While the values2 keyword gives the name of the variables that will be created from the data previously stored as the cell values. So here we use a colon named position to store weekly ranks of these 5 songs. And if we want to remove missing values coming from these original cells, simply turn on this values drop NA option. Then all missing values in the original data table will be removed. This pivot longer function could be more powerful than what I demonstrate here. I will show you another line of code to give you an idea of how versatile it could be. For example, if you are not happy with the prefix week in these week values, you can use the names prefix keyword to remove it from the output directly. And you can further convert the resulting digits of the character type into the integer type by using names ptypes keyword. And you should take chances to explore its potential when approaching real data tidying problems. In addition to converting data from the wide format to the long format, we can do the opposite, converting data from the long format to the wide format by using the pivot wider function, as shown by this line of code. Pivot wider uses ID colons to specify the colon or colons that work as identifiers for observations. And it defaults to all colons except for those specified by names from and values from keywords. Because we'll have more colons in the output, we need to use names from keyword to specify the colons from where we can get the names for those new colons. And the values from keyword is used to specify the colons we want to use to populate those output colons. And if values for some intersection of rows and colons did not exist in the source table, we can use the values field keyword to specify what values to substitute. Again, there are several parameters left undiscussed, partly due to the time limit we have, and partly because their functionalities kind of overlap those of several keywords in the dplyr package for data manipulation. But it could be fun to explore them with your real data problems, as they enable some shortcuts to combine the pivoting step with some useful data processing steps. For example, this keyword allows you to specify an aggregation function to quickly get a summary table based on your data. Sometimes, multiple variables are clumped together in one column. In such a situation, the tidyr package provides a separate function to tease them apart. Its usage is quite simple. Suppose we want to convert the date entered variable into 3 variables to store year, months, and day separately. We can first specify the colon to be split up, and then pass a character vector to specify the names of the 3 resulting colons. And the separate function will split values whenever it sees a character that is neither a letter nor a number. As a result, the year, months, and day parts of a date value are separated into 3 colons. This slide describes the specific meanings of several key parameters. You may wonder what this weird string means. It's actually an example of regular expressions for string matching, which we'll learn in the unit of string operations. A quick explanation here is the substring enclosed in the innermost parenthesis means an alphanumeric character. This caret denotes negation. Combined with this substring means a non-alphanumeric character. And the outside plus sign means one or more non-alphanumeric characters. Altogether, this regular expression matches any sequence of non-alphanumeric characters, and it instructs the separate function to split up values whenever a sequence of non-alphanumeric characters is encountered. In this case, the slashes in a date value. This keyword can also take numeric values, which will then be interpreted as positions to split at. Positive values start at 1 at the far left of the string, while negative values start at -1 at the far right of the string. And the tidyr package also provides the unite function, which does the opposite of the separate function. It combines multiple colons into a single character colon. Since the default separator used to combine these values is the underscore, here I set it to the slash, which is typical of the delimiters used in a date value. And since I list the day colon before the other 2 colons, values from this colon will precede those from the remaining colons. And this slide just gives you a summary of these key parameters. In practice, it is rarely the case that we can end up with the desired data form with a single data processing step. Normally, multiple or even a dozen of operations are needed, and thereby the corresponding functions are chained, with the output from a function being fed into the input of another successively. To compose a pipeline of successive function calls, traditionally, we combine functions via nesting, which works but is hard to read. The tidyverse provides a powerful tool, the pipe operator, denoted by this greater than sign surrounded by a pair of person signs, for clearly expressing a sequence of operations. With the pipe operator, we can chain these 2 operations to form a data processing pipeline. And the pipe operator takes the result of the function on the left and pipe it forward into the function on the right as its first argument. So we don't need to specify the first argument for a function on the right-hand side of a pipe anymore. Actually, we can unroll any function with this operator. It allows us to rewrite old-fashioned nesting of function calls in a way that flows and feels natural. We can also use a pipe operator with indexing operators by using the dot as a placeholder for the passed-in object. The pipe operator also minimizes the need for local variables and function definitions, and allows us to easily end steps anywhere in the sequence of operations. In my opinion, the pipe operator is a great addition to R. Once you get familiar with its syntax, you'll love it. And because the pipe operator is used throughout the tidyverse and loaded automatically when using packages in the tidyverse, you don't need to load the pipe operator explicitly. Actually, the pipe operator is more flexible than you thought. It allows you to pipe forward an argument other than the first one by using this placeholder. You can also specify other arguments in terms of the first argument by populating the placeholder at different places in a function call. And if you want to suppress the first argument rule of the pipe operator, you can simply enclose a function on the right-hand side of a pipe in braces. From now on, we'll heavily use the pipe operator in our R code.